Welcome to Static Electricity. Hola! So you're going to learn all about electric charges and static electricity and electric discharge. So fun.
Okay, so before we start static electricity, it's probably important that you know what we mean when we talk about a charge, okay? So objects can become charged or they can be balanced, and it all depends on the number of protons and electrons that they have, okay? Electrons are negatively charged, so if an object gains an electron, it's going to become negatively charged. If it loses an electron, it's going to become positively charged, all right? You cannot have charges that are destroyed. They just move from place to place.
So charging is not the same as credit cards?
No, but it would be awesome if it was.
Just in case you don't remember from 6th grade, these little blue guys are not real blue in real life. I don't think they have a color in real life. The little blue guys whizzing around are the electrons. They're like hyperactive little 5-year-olds on Mountain Dew. They go super fast on the outside. So excluded.
They're kind of like planets revolving around a sun.
Whoa, connection. The guys in the middle, the red and the green guys, are not Christmas ornaments, even though they look like that. One would be protons, one are the neutrons. So protons are positive, PP, PP. Neutrons are neutral. Anything else?
Nope. Move it. Okay, so we just talked about how objects can gain or lose electrons, okay? So loss of an electron becomes positive because now it has more protons, PP, protons, positive, okay? What else?
Don't you like this little, like, cow?
And how it's a dog.
Animal.
Okay.
And the animal has this hair up here, and you're rubbing this plastic rod on top of the hair, and then if you notice, the rod has all these plus marks, indicating more protons than electrons. And just to let you know, FYI, in real life, there's a kabillions of electrons and protons here, but we can't draw that many. So we just represent it with a few. Just a little tidbit.
Okay, so if an object has the same number of protons and the same number of electrons, so the same positive number of charges and the same negative number of charges, then it's going to be what we call neutral, okay? It doesn't have a charge. So it's not going to attract to any objects and it's not going to repel from any objects because it is not a charged object.
So it's like the socks that don't stick inside your pants.
Or the dryer sheets that don't stick to your
dryer
clothes.
sheets are good, and they make your clothes smell. Yum.
Yep,
So if
use
you look,
dryer sheets.
positives 3, negatives 3, bada bing, neutral. Negative objects. I don't know why some things are just so negative. I guess they've had a bad day. Or they've gained electrons. So in this picture, you can tell we Googled, but in this picture, the blue guys represent electrons. In the blue guys, there's a lot more electrons on this polythene rod. That means plastic.
Big word.
So as a classic thing, you just rub the polythene rod with a cloth, and you're transferring electrons to the rod. So the rod becomes charged. You can zap people.
So if you ever go home and your mom asks you if you had a bad day, you can say, no, I just gained electrons.
Aw, science. Okay, 3 ways to charge it. Get it, charge it, get it. You got it, you're funny. Okay, number 1. Now this is going in your note guide on the right-hand side. On the top would be friction, and friction is kind of easy because you've seen like rubbing things together, and that's friction. So friction is when you transfer electrons by rubbing an uncharged object to another by just rubbing it in. So classic, balloon, hair, rub, crazy hair. And you'll notice that they're all neutral here, but we're transferring a lot of electrons to the balloon. But look at this lady's hair, and I don't know why she's wearing sunglasses, but she is, and look at all the positives here. So they're repelling each other. All these positive strands are pushing away because they're like, oh, you're positive, so am I. We've got to like separate.
And they want to go towards the balloon because now the balloon is negatively charged and opposites attract, so our hair is attracted to the balloon. Okay, so another way that an object can become charged is through induction, okay? So this is when 2 objects are in close enough proximity and they have opposite charges, so proximity means close to one another, okay? And one is positive, one is negative, and there's an electric field between the 2. Because they're so close together, the transfer of electrons occurs without any touching required.
Very magical, but think of a winter day, carpet on the ground, doorknob, zippity zap, before you even touch it, zippity zap. Happens with outlets too, and light switches.
Yeah, and sometimes too, tell me if I'm wrong, when you
Perhaps.
take a sweatshirt off at night and you can see the like
Oh,
sparks.
that is so cool! Like,
Yeah. So I think that might happen through
Those
induction
fuzzy
too.
bed sheets do it. Like fuzzy blankets do it too.
Yeah. Mhm.
Fleece. Okay, number 3, conduction. I love conduction because it's through direct contact. So think of contact, conduction, CC. And so you're touching something and you get the charge. So this is a classic with this little magic house ball thingy called Van de Graaff machine. And the Van de Graaff machine, you touch it and you become charged.
Mhm. And you guys will actually get to use a Van de Graaff machine a little bit later on, as long as you are responsible children.
Okay, so basically static electricity isn't the time when you zap your friend or your sister or your brother. It is actually right before that. It's the building up of electric charges. Static means like not moving, really. So it's opposite of like the ones that you plug in. Those electrons flow. This is just the buildup of electrons. And then when you get to the zapping, it's called something else.
It's called static discharge. So think of static electricity kind of as the beginning of building a structure or building a building, okay? It's the final product then is the static discharge. That's what you actually want to see. That's when it's all complete, okay? So static discharge happens when a negative object, okay, and a positive object are brought close together, and then the electrons transfer between them. So those are kind of the 3 things we just talked about where the buildup of static electricity can happen one of 3 ways. And then that spark that you see or that reaction that you see is the static discharge so both objects are trying to return back to their neutral state.
So they keep on transferring until when? Like when do electrons know to stop?
So they'll know to stop whenever they have the same amount of electrons in the
Got
object
it.
as they have protons. So you picking up what I'm putting down?
I'm picking it up.
All right.
Smelling what you're stepping in.
Ooh.
Recap, 3 ways to charge it. Friction, induction, conduction. Static electricity is not the zap. It occurs before the zap. It's the shuffling your feet across the carpet.
Mm-hmm.
The zap is a discharge. Just like when you get discharged from a hospital. If you've ever been to a hospital, you're leaving. When you get static discharge, your charges are leaving. Okay, adios.
Later.
How do we, oh yeah, F10.